Welcome to the Strategic Energy Group Building Operator Smart Series. This is part 2 of our 8-part series, Benchmarking, Keeping Score. For additional energy reducing tips in your building, please subscribe to our YouTube channel by clicking on the subscribe button. My name is Scott Legge, and I'm an energy coach with Strategic Energy Group. These 4 items are widely recognized as top areas of savings opportunities in existing buildings: equipment scheduling, appropriate use of outside air, simultaneous heating and cooling, and sensor calibration. You might have noticed that all 4 of these involve only the HVAC systems. Well, while lighting systems oftentimes have significant energy savings opportunities, we find most lighting issues and their opportunities tend to be more easily recognized and therefore more readily addressed. Yet the HVAC systems generally exist out of sight and tend to be complicated and more difficult to understand. As a result, HVAC savings opportunities are largely unrecognized and frequently overlooked. In this video, I'll discuss several methods of benchmarking your buildings in order for you to prioritize your energy management activities, as well as some ways you can verify your building's equipment is following the schedules you've set. Many building operators are responsible for more than just one building, and they must be able to prioritize their time and resources to ensure the buildings are maintained properly and within budget. Not all buildings use energy at the same rate, however. For example, a small building that's poorly controlled could use more energy than a much larger building. When beginning a strategic energy management program, you'll want to prioritize your buildings and focus on the worst performers first. Benchmarking all the buildings in your portfolio is a good way to compare a building's consumption rate against other similar types of buildings. To benchmark, we typically use a measurement called the Energy Use Intensity Value, or EUI. This provides us with a single common value for each building that makes it easier to compare them to one another. Calculating the EUI is a simple procedure. You'll want to gather your annual consumption for electricity and natural gas first. First, convert the building's electricity and natural gas into a common unit, the British thermal unit. Multiply your annual kilowatt hours by 3,413. Multiply your annual gas usage by 100,000. Next, get your building's gross square footage. If you add your gas and electric BTUs and divide that number by gross square footage, you'll have your building's EUI. Once we have the EUI value for each building, it's easy to compare it against other buildings in your portfolio of buildings. The buildings with the highest EUI are likely the worst performers and should be made your highest priority. Depending on whether the buildings have different uses or extended schedules, you may still need to take some additional factors into account. For example, in a portfolio of college buildings, chemistry and athletics buildings will usually have much higher EUI values simply due to their purpose. So even though they may have the highest EUIs on the campus, it doesn't necessarily mean that they're the worst performers. Once you know the EUI, you have a convenient method to compare a building's performance against other buildings of similar type and usage, both locally and even nationally. Benchmarking also provides a baseline value for monitoring and tracking a building's performance as it progresses over time. Once you've determined your building's EUI, you can compare your buildings to other buildings of similar type. Currently, an EUI of around 70 kBTU per square foot is considered the median EUI value for a typical office building. But that still isn't considered to be an efficiently operating office building. To find target values for what's considered an efficient building, ASHRAE has developed Standard 100-2018 that sets EUI target values for energy efficient existing buildings. It covers most all of the common building types and lists the target EUI values by climate zones. Here you can see that Western Oregon is in climate zone 4C. You can see that the chart says an office building should have an EUI of 40 or lower. Central and Eastern Oregon is in Zone B. And you can see here the chart says an office building should be 42 or lower. Another very popular benchmarking tool that many of you might be familiar with is Energy Star's Portfolio Manager. It's a free online tool provided by the United States Department of Energy. It provides both the EUI value for each building as well as an Energy Star score. The Energy Star score is a 0 to 100 reference as to how your building compares against a subset of similar type of buildings. Office buildings, schools, hospitals, things of that nature. Now note here, the higher the Energy Star score, the more efficient the building is, as opposed to EUI, where a higher number means a worse performer. We're going to shift gears here now and talk about night walks and other methods to verify your building schedules. In the previous video, you saw how important it is to keep your equipment schedules updated, and to verify that equipment is actually doing what you think it's doing is very important to operating an efficient building. Now, night walks are one of the very best ways to verify what's actually happening in your buildings after hours, and you may be surprised to find the results. When a building operates 24/7, it's usually quite comfortable when people arrive in the morning, and so nobody complains. Without complaints, there may be no reason to give it a second thought. Consequently, what's perceived as your best behaving building may actually be your worst energy performer. The goal of the night walk is to walk through the building when it's completely unoccupied and all the equipment is expected to be off. And you want to do this after the janitorial staff has left. Also, don't let anyone know ahead of time that you'll be performing a night walk inspection. You want to see the normal operations, not their very best behavior. Now, for walking the building, look, listen, and feel during your night walk. Look for anything that's on that is not needed. The goal here is to find anything running needlessly. Listen. Can you hear the rumbling of equipment or the airflow whistling through ductwork? Can you feel any air currents flowing as you move about the building? That could indicate fan systems running or perhaps a leaky building envelope. Realize also that night low limit and night high limit can bring systems on for short periods of time overnight. So when you find HVAC running, make a note of the time, as well as the building temperature and the outside air temperature at the time. These could be helpful to know when investigating further. You can compare this to trends in your BAS and determine if they were actually supposed to be on. Lighting may be the most obvious opportunity you'll encounter during a night walk. You'll likely notice that most buildings will have some emergency or egress lighting running all night, but it should be minimal, just enough to allow safe egress from the building when it's dark. Make a note to investigate it if it seems excessive. Also note any rooms, hallways, or section of the building with many lights still left on. The hallway in this picture is a real example from a high school at night. In this case, there were no accessible switches for the custodial crew to use to shut the hallway lights off, so they were just left on, always. If you find lights left on, look to see how they're switched. If it's manual, see who's responsible for shutting them off, and make sure they know where the switches are located and that they know that they're responsible for turning them off at night. Lighting controls don't always act as expected, so unless you make a visit after hours, you may never know what's misbehaving. You may find broken equipment or controllers that need reprogramming, or something as simple as the controller clock simply needs to be set. And don't overlook exterior lighting as an opportunity to save energy. You'll likely find some miscellaneous plug loads during your night walk, such as all of these computers running. If this is an issue at your facility, talk to your IT department about automated software systems that can shut computers off after hours or put them to sleep, and then wake them up if needed for software updates to take place. Also, keep an eye out for printers or copiers that are not in power saving mode. Night walks are also a great time to look under desks and find what's usually hidden out of sight. Look for space heaters, especially check to see if they're still running. Space heaters could actually be a fire danger. How about mini fridges? In kitchen areas, also look for coffee makers that are left on, or maybe cooking hood fans that are still running. If you have vending machines, are they all lit up? If they are, use a plug-in time clock or a vending miser if possible. Night walks are a good time to check the mechanical rooms for equipment that's still running, like air handlers, fans, boilers, chillers, and pumps. Can you find any general exhaust fans, bathroom exhaust fans, or kitchen hood exhaust systems that are still running? These systems are occasionally overlooked and never tied into the automated control systems, even if it's part of the installation contract. These systems could operate 24/7 for years before anyone notices it. Also realize if fans continue to run when the rest of the HVAC is turned off, they're exhausting your energy outdoors, essentially throwing conditioned air right out of the building. For schools, be sure to check classrooms. They frequently have unit vents which provide ventilation, heating, and cooling. Are they shut off at night? Are they shut off over holidays and weekends? Whether during a night walk or even a daytime site visit, always keep an eye out for equipment that's been overridden. It's pretty common to find systems that have been overridden on months earlier due to a brief weather event or maybe some maintenance, but now it's been forgotten. It's also important to review the HVAC systems immediately after a cold or hot weather event to make sure that you catch any overridden equipment that may have been forgotten and is now needlessly running 24/7. A good way to verify operations without doing a night walk is to utilize trend graphing. Today, most building automation systems have trend graphing capability built in. Unfortunately, the installing technicians rarely set up a comprehensive series of trend graphs for you, so you'll probably need to set up a few of your own. Trend logging and graphing are valuable tools for troubleshooting and verification of your building systems. They can also help you find energy savings opportunities. Now in this graph, the blue line represents the fan status, and the purple line represents the outside air damper position. The fan system appears to have optimal start and morning warm-up functioning. Notice how the optimal start time varies here sometime after 5 o'clock in the morning. Notice also that the dampers remain closed during the early start time. This is what we want them to do. There's no sense in having to heat up cold outside air when nobody has arrived in the building yet. Note this low limit spike around midnight running until about 2. The dampers here are kept shut, and again, this is what we want them to do. The system will be able to provide all of its heat into getting the building back above the night low limit temperature again. So from the information we see here, this system appears to be operating correctly. In this example, the red represents the fan command and appears to be following a weekly schedule, coming on at 5 and going off at 7. The blue line represents the actual status for the fan, and it seems to be stuck on, never shutting off. The purple line represents the outside air damper command, and it's set for 20%. This trend log is showing that the fan is stuck on and the outside air dampers are set for 20%, and it doesn't change. So not only is this fan system using electricity 24/7, but since the dampers are not shut after hours, the system is using energy to condition outside air 24/7. This will drive up both electric consumption as well as gas consumption. So finding and fixing the root cause of this one will likely be a very good energy saver. Here we have an example of a load profiling tool. In this graph, each colored line represents a different daily load profile, and it shows 7 days superimposed over each other. I really like these tools as they provide a quick and easy way of monitoring building performance and schedules. You can easily see when equipment begins to come on daily, and then how it ramps down again towards the evening. Note how the 2 weekend day usage remains flat. This confirms weekend scheduling is implemented. Note there's a 200 kilowatt base load where the consumption never goes below this level. Most all buildings will have a base load that they simply don't drop below at any time. But in this example, 200 kilowatts after hours, there may be some opportunities here for savings. Here's a great example of load profiling. This one shows a whole month of daily load profiles, and in this case, the HVAC systems have been temporarily scheduled on to run for only a single weekend. Unfortunately, it was done using the weekly scheduling feature and then forgotten. Had they used the available event scheduler option for a one-time event, the override could have been scheduled to last only the 2 days it was intended for, and then it would have automatically reverted back to the normal weekly schedule again. The weekend overrides remained on for 3 months in this example, till it was finally noticed and brought to their attention. This simple oversight cost this facility an extra $30,000 in electricity. And this is a very common problem that I've seen. So periodically reviewing schedules and reviewing performance is very important for all facilities. Heat maps are another great tool for verifying building performance. In this graph, the vertical scale on the left is for each day of operation, while the horizontal scale across the top shows each hour of the day. The green represents low energy consumption and the red indicates higher consumption. Note how the operating patterns are quickly discernible. Evening and weekends show up as green versus bright red for the occupied time of the week. You can see here Monday, January 16th, that's Martin Luther King Jr. Day, and the building was unoccupied for the holiday. Yet it's still showing red, which means considerable consumption was happening all day. It's most likely that the HVAC wasn't scheduled off to capture the savings available over the holiday. Thank you for watching. We hope this video helps you find savings opportunities in your buildings, and I hope you'll watch the rest of the videos in our Building Operator Smart series. For additional energy reducing tips in your building, please subscribe to our YouTube channel by clicking on the subscribe button.